I'm joined today by Trevor Lithgow, who is the director of the Center to Impact AMR Strategy in Australia, actually in Victoria, at Monash University in the state of Victoria. And the theme for our theme for today really is going to revolve around kind of what's going on in Australia. We're been very interested recently in seeing a variety of national initiatives emerge, and so I think it's really fun and timely to visit with people in different parts of the world about what's going on. So, Trevor, thank you for being here today. Really glad we could connect.
The pleasure's all mine, John. Thanks.
So I know of you in general as a sort of a molecular microbiologist and some interest in phage therapy. But let's before we go into kind of what you're doing these days, tell me a little bit about you. How did you get interested in antimicrobial resistance? How did you wind up where you are?
Yeah. It's a sort of long and winding road, so I'll take the short version of it for you. But my background is in molecular biology, and I've always been interested in microbes. So they've been the experimental systems of choice in my lab. So I did my postdoctoral work at the University of Basel with Gottfried Schatz, looking at how the proteins that generate mitochondria actually get into that organelle. And that led me to an interest when I established my own lab of starting to work towards understanding how the mitochondrial outer membrane was made. I've always been interested in membranes and membrane biology. And since we know that mitochondria evolved from bacteria, the more we learned about how mitochondrial outer membranes were made, the more we got interested in why it was we didn't know more about how bacterial outer membranes were made. And so at the time that I moved to Monash University, which is like 12 years ago, I decided to shift the focus of the lab away from the mitochondrial outer membrane and to start working on the bacterial outer membrane. The sort of approaches we take uses structural biology, classic molecular biology, and because we were working with E. coli and Klebsiella as our bacterial models, a lot of microbiology, which I knew from before and was able to bring back into the lab, especially with great colleagues at Monash. So it was a really great move for me personally, for the people in my lab, and I think also for the science that we've been doing. And as soon as we started to work on the outer membranes of gram-negative bacteria, it was really made crystal clear to us that the major motivator for understanding these processes in the bacteria was really because of the evolution of antimicrobial resistant phenotypes and the way in which the outer membrane is sort of front and center for how some of those phenotypes develop.
Fascinating. And you're going to need to give us all a little bit of some context around how you might think about developing drugs to target the membrane per se. I guess I think about amphotericin B attacking fungal membranes.
Yeah.
I don't think of any of our current agents as interfering with, we want to call it lipid biochemistry. Would that be a fair thing to say that's not been an area that we've explored a lot?
Yeah, I mean, that's definitely true. It's not that that's been a major focus. That is definitely true. I guess we have sort of last line antibiotics like the polymyxins that will attack the lipid phase of the outer membrane, or not so much attack, but they're interactive there, and so exert part of their effects there. What we've started to see generated out of several labs, not mine, but several labs just in the last year or so, small molecules that attack the machinery that puts the proteins into the outer membrane. And I think so in that sense, we're coming back to classic antibiotic territory where it's a protein-based target that these small molecules would go after. We know that the machinery that's in the outer membrane that puts all the other proteins into the outer membrane, that is surface exposed. So you can take antibodies and they can find epitopes on those machines from the outside surface. And that was really the first step towards imagining that there would be molecules which could see those same externally exposed surfaces. I think that the cool thing about those sorts of drugs, if indeed these compounds end up being drugs, is that while I suspect there's always going to be a way for resistance to a drug to evolve in bacteria, given the canny process of evolution. I think the great strength of having something which hits the bacterium from the outside surface is that there's no way that they can develop pumps that would be effective at getting rid of those molecules because they never got in the first place.
Right.
And there's a limited number of modifications that could be made to the machinery as a target to make it resistant to the effects of the drugs. And so as long as there's limitations on what can be done, you could imagine that some clever chemistry on the drugs might be able to be really effective against these sorts of targets.
Yeah, it's one of the things I learned by listening to the discovery groups I was for a while at AstraZeneca and listened to them talk about large macromolecular interactions like that, is that the big interactions like that are hard to interfere with small molecules because there's so many pieces of it all at once. And that, of course, is the reason people are interested in the single enzyme targets. Fascinating, excellent. So let's actually step back to the thing that sort of provoked this particular conversation, which is what's going on in Australia and what is the Center to Impact AMR, and basically, what are you up to?
Yeah, well, thank you for asking. Australia, like everywhere else in the world, has for some time now been taking this problem of antimicrobial resistance seriously. I feel, from inside the tent here, I feel that we've got a good perspective of the fact that AMR is a global problem. It needs, collaborative work across countries' borders in order to have any real sense that we're going to make an impact on AMR. And so I think Australia is sort of keeping up reasonably well in terms of what we will need to do and getting a sense of through our national strategy, which, we have one, and I think it's pretty decent. It's not so different from the national strategies of other countries, which is a good thing. I think we're all seeing the problem for what it is. We've also been involved just recently in consulting with the state government here. So the way things work in Australia is that there's a certain amount of funding and means that can get behind you at a national level delivered through our research councils and a National Medical Research Future Fund. There's a certain amount of funding that's there, and so the national strategy is important for helping to see how that money should be spent in terms of having real impact on a problem like AMR. But in addition, there's the state government has investment that it wants to make into this problem. And so we've been consulting with parts of the state government to try and develop their state government AMR strategy. The reason to get the consultation and the reason we were keen to help is that it's really important that the state strategy aligns with the national strategy so that we've got the best possible way forward. But it's also really important to recognise that in the different states, Australia is a small country, and so in the different states, it's actually quite a different makeup of people and therefore capabilities within the university sector in particular. And so we need to play to our strengths in the various states. We need to invest the state money in the state in the way in which it's going to have the most possible impact against AMR. And so we're really glad to have been invited to consult on this. And I think the state government's moving forward really well with a strategy that's starting to look like something that can do some real good. I guess we're also careful in Australia to so I think it's really important. Up until now, one of the major troubles, as you know very well, one of the major troubles with AMR has been this difficulty in getting the investment that's needed to develop new drugs, given that the old drugs are falling into, disuse because of AMR. I think in many respects, in a country like Australia, we've sort of, the pendulum has really swung a bit too far in the other direction, where the messaging now, especially at the government level, and therefore at the level where the spending might be done, the messaging now is almost that if only we could get one more drug, there'd be no problem with AMR and we wouldn't have to worry anymore. And so we've been really careful. Obviously, we need new drugs. And now I think internationally, there's some really great strategies. CARB-X is one. People are really thinking in new ways to try and make sure that new drugs will be coming up, and there won't be just one and then we're done. But, there will be, let's hope, a timeline of new drugs coming into clinical use. The issue, of course, is that that's not a solution to AMR. That's just kicking the problem forward. Every new drug kicks the problem forward a few years. It saves many lives. It's really important, but it doesn't change the fact that, AMR will catch up. And so what we've been trying to make clear, and in fact, the reason we started this Centre to Impact AMR 2 years ago, was to try and push this idea that the sustainable solutions to AMR are not just a new drug, and also not just much better stewardship of the existing drugs, but that there's a whole lot of other things you need to get right if you're going to change the way in which this evolutionary attack on the drugs happens, and therefore extend the window that each new drug would be useful. And what we put as our sort of major aim in the centre is thinking of ways in which we can bring some of the drugs that were already made, the investment was made, they're working really well, but bring them back out of the cupboard and start using them again by putting pressure on the evolution of AMR to sort of try and reverse that evolution phenotype backwards.
So repurposing old drugs or restoring old drugs, in what ways?
Yeah. So repurposing drugs, I think, is fantastic as an idea. And I think there are some really nice examples of where drugs that are used for other conditions, especially drugs that would promote immune function, promote immune function and makes them useful in this clinical syndrome or that clinical syndrome, can also make them useful in treating an infection. I think that's a beautiful strategy, and it's such a neat way of making sure you get the most out of given treatments that are already effective. I think the idea of restoring the use of antibiotics. So, for example, I like to think of this, the development of carbapenems as being one of these great stories in the way in which we can try and fight against the evolution of AMR and ultimately come up with something that really should have been a great drug, and in fact still is. The carbapenems still are great drugs. But we, of course, know that there's now a build-up of carbapenem resistance in several different species of bacteria, and they're the ones that are causing a lot of grief in hospitals. But there's no reason why we can't think of ways and start to do things that would diminish the advantage that a carbapenem-resistant bacterium has, to try and make the case, as if we could argue to the bacterium, to try and make the case that it's in its best interests to be carbapenem sensitive, and then when need to use carbapenems to treat an infection. And there we're thinking of things like making sure that whatever bacteria would be in a clinical or non-clinical environment, that there'd be selective advantage for those populations to be carbapenem sensitive and selective disadvantage to be carbapenem resistant. That includes the simplest things like good stewardship, so that you're not washing lots of carbapenems down the sink. But also bacteriophage, I think, are a great way of putting an alternative pressure on a population of bacterium, so that being drug resistant is selectively bad, and you therefore create a population of drug sensitive bacteria. And those are the sorts of ideas that drive our research in a big way.
So you're thinking, it's interesting, you're thinking about using phage not directly or not necessarily to be bacteriolytic, but phage to deliver things that actually clear resistance cassettes. I know there's been some discussion of use of, I would use broadly the CRISPR technologies, but even more broadly, the various DNA editing technologies to drive resistance out of bacteria as a tool, to actually convert it to retrofit back to susceptibility. Is that the direction you're pointing?
So that's like the high tech, the beauty of the 21st century of gene editing technology, and I think those ideas are fantastic. And there are some serious hurdles with those sorts of approaches, including just implementation in a clinical setting where you're using a genetically modified organism or trying to create a genetically modified organism. And so I think those hurdles are not insurmountable, so they can be gotten over, but I think they are significant hurdles. And so that, again, that means that the time frame for implementation of those therapies is a long way off. So the fundamental work being done towards that is absolutely great, and I love reading about it, but that's not what we're doing. What we're doing is more aimed at using natural phages. We go out of our way to study phage from environments that are not normally used for the discovery of phage, but that's really just to try and help to cover a breadth of phage types that can be accessed as natural phages that could be used in phage therapy. But the phages that we're looking at it's using the fundamental biology we already know. So, for example, a great example that we discuss and which we're actually moving on towards using in phage therapy here in Australia would be phage that attack the capsule of Klebsiella, for example, or Enterobacter or Acinetobacter, any of these capsulated bacteria. So you take a phage, and there's many of them, phages that would attack the capsule. Now, if the bacterium wants to become phage resistant, all it has to do, and what the population will do, is to modify some of the genes that make capsule, and the unencapsulated bacteria become phage resistant. And being simple-minded organisms, they're probably pretty happy with that as an outcome for the population. But we know that the unencapsulated bacteria are much more drug sensitive because the capsule is a major protective layer of the bacterium. We know also that there are certain outer membrane proteins that would be targets for phage, where if you hit them, changes that would result in that receptor going away and the bacterium becoming phage resistant will mean that they can't afford to lose their major porins. And since the major porins are the conduits through which most drugs would get into the bacterium, this again is a strategy which, you know, in the lab we can show does work, and where we would only be using natural agents, which it's not a done deal that you can get them in the clinic, but it's starting to, you know, things are starting to change where these, on a fairly short timeline, these things could become useful therapies.
Fascinating. So this whole, I'm hearing the theme of membrane biology running through your research and the work at the Center to Impact AMR. And so it sounds, it's fun. It sounds to me like you're actually getting, we'll use the word state and federal level support for doing this kind of research, and good. In the broader AMR strategy for Australia, has there been any discussion that you've heard about the concepts of, use broadly the idea of push and pull incentives, this notion of needing to pick up antibiotics, because you said a minute ago, we don't need just one drug, we need the next 4 or 5. And we actually need to create them and then have them available and maybe not use them very often, which has a clear financial negative to it from the standpoint of the innovator. Is there any conversation that you're aware of in Australia that has to do with thinking about the large-scale incentive structures that would actually drive the whole ecosystem to cause people to invest in the space?
Yeah, so there is, I would say, it's perhaps fair to say that it's early days in Australia in this regard, and I would say that's definitely fair to say if we compare ourselves to the US, for example, but it's
or to compare anybody to the UK. The UK is the ones who are way out ahead on this, right? The US, we're poking at the Pasteur Act, and we sure hope that makes it. But just to be fair, Europe has started to do some stuff as well. But so I don't think any of us are that far behind. This has all happened in just the last year. So you don't need to be too apologetic about it. So if you're engaged at all, that's a big deal.
Yeah, well, I think that's definitely true. So there's a national network that's been formed called AMRnet. The first A being for Australia. So this is a national network that's been formed by some really smart people that are motivated by federal government. Well, there's small funding, but there's quite big strategic interaction in AMRnet. Our centre is a member, as are the other centres in Australia who are interested in AMR. It's quite it's an open network, so it's not an exclusive club. And I think there's clarity around which are the centres or individual operations that are not centres in Australia, which are moving hard on trying to be involved in international collaborations to deliver new drugs. And I would maybe make a shout out to one of my colleagues up at University of Queensland, Mark Blaskovich, who's one of the lead people, I would say, in Australia, in terms of being hooked in. So some of Mark's work has got CARB-X funding already. AMRNet is working with Mark to sort of develop some of their operations. They have a very nice collaboration. I think it's still a live collaboration with Emory University for drug discovery and drug development. And so I think, again, Australia is a small country, and if every one of us tries to do everything, we're never going to make it. But I think there is a certain, perhaps just in the last few years, there's been a really clear understanding that, there's turf that makes sense for an Australian-sized operation to cover. And if each of the operations can see their own turf, then there's no reason why we can't be working together on something which, as we keep on saying, is, such a global problem that it doesn't make any sense to just be secretive about doing your own thing. So I think Australia is in a good position, I would say, overall, in terms of working out creative ways that we can be a part of both the push and pull incentives around drug discovery and drug development.
Yeah. I am increasingly impressed with the need for, political leadership. And you keep saying Australia's a small country. You're a wonderful country it's got a wealthy, advanced economy and the ability to set a good example. And I think that's a theme that we're seeing. We're hoping to see with the countries in Europe taking that approach. I mean, every little bit helps. And I personally just remain concerned that if we don't actually get some decent delinked, we buy it like it's a fire extinguisher kind of incentives down the road, that all of this work will will end up sputtering out because the cost of maintaining the product once it's been developed. You're at the beginning stages, sort of the fun stages of drug discovery or product discovery. As you get further into it, you hit all the issues of, stable manufacturing. I'll just say, like the whole phage concept. I've always thought phage clearly can kill bacteria. There's no question that they work, and yet the problem is the delivery to. Well, now I'm Dr. Busy. I'm at the bedside. Here's my patient. I need something now. Okay, and I need to know that however you're preparing it, it's likely to work in a way that I can predict and understand. And for me, that has been the problem with phage, is the manufacturing of a thing that Dr. Busy can say, all right, I believe in that. And it may not be the same as what you gave me for my other patient, but you've told me how you make it, and I get it, that this variation ought to be correct for this patient, not for that patient, but for this patient. So I think that what you'll discover as you get further into it is that the harder part of the whole phage story is that part. It's the credible, on-the-spot manufacturing of the tool that is needed. And we do have some examples. Flu vaccines are a really good example of a product we recreate every year, or at least until we have an mRNA flu vaccine, and then that's a different story. But up until now we've made it again every year, but we trust it every year because we know the process. And so I commend you for your work on phage. Somebody's going to crack that nut one day. Might as well be you. And to me, the hardest thing about it isn't the idea that phage can kill. I believe that we've seen that work. The hard thing is the manufacturing and giving me something that comes to me in a vial that I can use right now in this person without too much more fuss, because that's what you expect from any medicinal, is that you know who to give it to, and you know how much to give them, and you know what to expect. And here I think you've got the same interesting challenge. And so if I come back to sort of wind up here thinking about Australia as a whole, national strategy and a local strategy that includes investing in in a research project-based center. Fantastic. What are you doing about education? Something else I worry about is, I'm getting old. I won't speak for you, but I know I'm getting old, and we need to train other folks. And Patrice Corvalon has this great annual course where you can go and get a week's worth of intensive infection insight. What are you seeing in terms of growth of young people and getting people interested in this? And is that coming together in Australia and coming
Yeah.
together in Southeast in Asia?
Yeah. So firstly, our centre does have a regional focus. So it's not just an Australian centre. We do have partnerships with countries in Southeast Asia and also in Oceania. I'm gesticulating as if I had a world map here in front of me.
I'm
So
seeing it. It's good.
so we are interacting at that level. I think our education focus I was going to say it's two parts, but it's a sort of a spectrum of parts that includes, the next generation of people who are going to be working in AMR and working to solve problems in AMR. And so I can speak a little bit about that. But I think another really crucial part that usually misses the bus when we're talking, like when researchers are talking about a problem like AMR, and we decided that the centre was not going to miss that bus, and that is to educate the public so that they actually know what the problem of AMR is.
Thank you. Yes.
And I think that has knock-on effects, because if you have, let's just call it, let's say the next generation will be an AMR savvy public, then all of the people you're recruiting into universities for whatever sort of work they'll do, whether it's scientific research, engineering, social sciences, whatever, they come with at least a foundation knowledge of what the problem probably still is in that generation. So we've started working. So in fact, coming back to this idea of a state strategy here, state government in Australia is responsible for education. So the federal government does a few things, but the state government delivers education and health. And so we are now working, we have members of the centre who are from the Faculty of Education, members from the Faculty of Arts and Humanities. And so we've started to work on a program of teaching teachers to teach middle school, so sort of in the range of 12 to 15-year-old kids, about AMR, and using AMR as a framework to understand things from both the sciences and also the social sciences and humanities. And the idea here would be, that the knowledge that we would want to impart is everything from what's the difference between a bacterium and a virus in terms of the diseases they cause and how you keep control of them.
Wonderful.
Delivering the important messages that come out of sort of the hygiene hypothesis and the fact that you don't need to obliterate every microbe in your house to think it's clean, but rather just keep it hygienic and let the drug sensitive ones grow because they're keeping out the drug resistant ones. So trying to do everything and delivering messages like we can wash our hands and be safe against even terrible things like SARS-2 using soap. And it doesn't have to be soap loaded up with antimicrobial chemicals where tons of it are now being washed into the environment. And, we're just setting up a problem for 10 years from now where we'll start going, oh, why didn't we change the soap that we used during the pandemic? So we're working on those sorts of education. That's education. And then moving towards this more sort of formal and normal university education of taking people coming out of high school into bachelor degrees and teaching them about AMR and trying to enthuse them that, at the moment in Australia, I would say the smart kids that are finishing their undergraduate degrees and thinking about a career in research are still thinking about cancer and curing cancer and making sure that cancer is not a problem, and getting them interested in the idea of something that is not the problem that they see in their families and perhaps not the thing that, they want to discuss at a dinner party, but nonetheless is the thing that they really should hone their skills on. That's still an issue, but I think that's that's a matter of more information to people who are at a level of education where they can really get the information that you deliver, right?
Well, and you'd hope that at the end of that, there'd be some people who decide they want to put their time and their money into doing research in this area. But I love the idea of science modules for kids in middle school. I mean, that's bully for you, bully for you. Well, I say this has been fun. It's good to see that you guys are engaged. I'm delighted to hear about the research at your center. And what haven't we covered that we ought to talk about in terms of what's going on in the land down under about AMR?
Yeah, I think there's perhaps one thing that I would just like to I don't know I'm choosing my words carefully because I want to make sure it's a parting gift and not just another meaty conversation, because this really has been fun, John, and I've really enjoyed it. So you mentioned, and it was kind of a challenge that I will take seriously. You mentioned this idea that the next and the difficult phase for phage therapy is this idea of helping Dr. Busy to have the product that's there in the hospital pharmacy that can be delivered when the patient needs it in a way that's trusted and able to be used with confidence. So I just wanted to perhaps let you know that we should get together sometime in the next few years to touch point on this again, because we've got this operation in Australia called Phage Australia. So the Centre to Impact AMR is part of this national agenda, and that national agenda is being led by clinicians from the various states, from the major hospitals around Australia. It's headed by a really great leader called John Iredale, who has decided, I would say with vision, that phage therapy could be made possible in Australian hospitals. And so we've applied to the federal government's Medical Research Future Fund, and we've been granted the first stage of funding there. So we'll see how we go with the second stage of funding, but the idea was exactly what you sort of rounded out there, that the need really is, we've got great people who are finding phage and doing the fun stuff, as you said. We've got clinicians who want to be able to use phage in ways that we can imagine would be really effective. And we've now got a sort of consortium of researchers plus clinicians and some business interests that are keen to set up, and this is what we will do if we get the next phase of funding, is to set up a manufacturing process that would be done under all regulation that's needed, so that we can feed great new phage into that manufacturing process, and those phage can be delivered to the busy clinicians in a product form that they would be able to use. And we'll have to start at a sort of somewhere sensible. It won't be, now you don't need antibiotics scale. That's not probably ever going to be possible. But we are taking this issue seriously and trying to work against it. And our major motivator is actually that if we can try and do it and get somewhere with a good example, then that's a sort of thing that globally there'll be some, groups that will be able to perhaps do it better or more widespread or whatever it would be. So we're going to try and do that. And I'd love to perhaps bring you up to speed sometime in the future about whether or not that's been effective.
I'm happy to hear more about that. I should say that generically, the manufacturing and supply chain process is frequently, it's always at least as complicated as we call it the clinical development stuff. Even when it's something as simple as a tablet, the whole manufacturing supply process, to know that tablet made it to you, it never got too hot, it never got too cold, and it hasn't. So it's one of those areas that when I moved into the drug development into regulated industry 20 years ago, I was ignorant about the area, and I was so ignorant that I was ignorant that I was ignorant, if you'll permit me to say it that way. And over time, I have developed a great respect for the manufacturing, for the process, and the folks who know how to do that, and just be really sure you spend enough money on that, because if there's something that's going to get in trouble here, it's going to be that process isn't scalable, replicatable, isn't at an adequate quality. Things go wrong with that process. You're making something that is a tricky biologic, and you need to spend a lot of time and effort on that, and presumably also on the process that creates the right cocktail, or however you're selecting your phage for any given person. The sort of those technologies are things that there'll be a lot of inspection around to coming to the regulatory level. So forewarned is forearmed, and find the best manufacturing person you possibly can, and then find a couple more of them and put them all to work on this, because I really want somebody to solve the phage problem one of these days. That would be super. Well, thanks. This has been interesting to learn what you're doing. I am delighted to see the headway in the land down under, and COVID willing, we'll all be meeting at some antibacterial jamboree in the not too far distant future. But at least for now, we can be grateful to Zoom for making it possible for us to chat. So Um, uh, Stay safe. It's been a delight chatting with you, and we'll see you soon somewhere.
Yeah. Thanks for having me at your fireside. It was really great.
Well, what fun to get to visit with Trevor in Australia. Some really important and interesting activities going on in the land down under. And for those of you interested in phage therapy, clearly a lot going on that you might want to know about. I was unaware of the extent of the Australian national phage efforts. Cool stuff. So thanks for joining us. Thanks for listening in. And always remember to like, comment, and subscribe for more. And also below, look for their links down below, all kinds of things to read about. We'll be putting those in to guide you if you want to discover some of the things we've been talking about. Stay safe now.